So I've been working for automotive field. So at first I was in embedded field, then I moved to automotive field. So everywhere they in the industry, whether it is in IT industry or a automotive industry, they have a process. So here mainly they'll be going through V model process. So it is like a verification and validation process. That's why they call us V model. So that's what I just wanted to give you guys a idea, because when I was studying, I was not knowing how the industry works and what is the process or what are the technologies that they will be using. So I wanted you guys to have an idea before going for a interview or taking up any projects also. So it will be helpful for going through this kind of model process. So this is the V model process that is mostly undergoing with the IT or automotive field. So what happens here is it's like basic requirements. Like the customer will be giving the requirements. So we have to split it in a way that it will be not complicated in any stages. So like here, if you see, this is the requirement. So the customer will be getting the requirements from the customer. So so I will just explain first requirements, architecture, then there comes the design, then comes the implementation part. And this is nothing but the unit testing. First, I'm just explaining what all things are there. So unit testing, integration testing, and system testing. So it's like for every design, every architecture designing for all the requirements, we do the testing also. So whether the output, whatever we are expecting, it is we are able to achieve that results or not. For that purpose, we need the testing. Earlier, before V model, we were having a waterfall model. So what it will happen is this: requirements, architecture, detailed designing, implementation, then it goes to unit testing, integration testing, and accepted testing. But that was like a time consuming part, because if requirements is getting changed, then whole these things will be getting changed in waterfall model. Just a minute. Uh, So waterfall model is just a just what we usually do in our projects, in our college projects. So it's like a just a step-by-step process. But in industry, they don't prefer this, because that it will take more time. If there is any changes in the architecture, if suppose a microcontroller, ARM controller is not feasible for working with this project, then we have to change the architecture. At that time, the whole process will be changing again. So in order to avoid this, what companies, what people they have started is using V model. So what happens is, as soon as we do the requirements, we'll be writing the test plan. So how the requirements, so suppose, so I have just I'm making giving an example like LED in a microcontroller or any device, we have to just blink the LED. So that is our requirement. So we'll be writing what is it, the test plan as the LED has to be blinked. That is the main goal, right? So architecture comes like which architecture in industry, it's like um, which all models will be getting touched. Like for LED blinking, we'll be going with the hardware. So you might have studied like OSI, I mean 7 layers, like application layer, session layer, network layer. So those kind of layers, that is also still being used in industries. So here it's like a now LED blinking is just an application layer. So we have to just, it's like application that we are going to develop. So the architecture, we think that okay, we fix that the architecture will be changes has to be done only for the application layer. Then comes the detailed designing part is where we what kind of language to be used, like if Java or embedded C. Mostly where I was working, it will be used as embedded C language was used. And here which port, so now we have to blink the LED. So which port, what is a port number, those kind of things has to be we had to before writing the code, we had to finalize all these things, right? And then comes the coding. So while going through this process, we had to plan also. So XM testing, so how the LEDs has to blink. Integration testing, whether the architecture, so whether the architecture is having or has no problem. Yeah. and the designing. So here comes the unit testing, like whether the code itself. Now we have if condition. So if now how we write the codes. Just a minute, I'll just show you the source code, a simple source code. Now, suppose this is the LED blinking source code. So suppose here I'm giving, now the requirement is that the LED blinking should be like on off. So when it is on, after 1000 milliseconds or 1000 seconds, it should be off, right? So we can write a test case that whether this is 1000 or not, yet. So this kind of code, testing, just a unit testing, is called function testing. So this function itself will be getting tested. That is called unit testing. Integration testing is nothing but this whole code is getting tested with the whole project. Okay, so whether this code is compatible with our project, the whole software. So that comes with the integration testing. And system testing is nothing but, as I told, whether our output, whatever the requirement was there, that is getting that is working or not. That comes with the system testing. So this is how the V model process is going on. Okay. Now, why I am going with this process is actually I wanted to tell you guys about the Jenkins. This is a new technology that that is being used. So it's like a tool actually. What happens is actually here in the now suppose now we are working from home. Okay. So this unit testing, integration testing, this requires hardware. So now for automotive fields, they in IT at least they have a server, and in automatically, I mean, directly we can download the app and we can test. But for automotive field, the ECU is required. That is electronic control unit. So that hardware is required where we can flash and we can test our software. But since we are doing online, we are working from home, and so those kind of criteria will be there, and there will be some hardware issues also, like only one hardware will be available for a project, for a team. Then what to do? So multiple people will be struggling for having that hardware. What to do? So in that case, this testing part will be is getting automated. This part, requirement, architecture, detail designing, the coding, this part cannot be made as automated. It cannot be automated. It has to be manual. But this testing part can be made as automated. Yeah. For that purpose, they have used Jenkins. Yeah. Are you guys able to understand? Is it okay? Or I'm going a little fast?
No, sir.
Yeah. Okay. Thank you. So I'm giving you a demo. So Jenkins is a tool where we can automate our process. So that is the main aim of this Jenkins tool. So this is when I was given a training. So I was told that to get a hardware and test it using the Jenkins tool. So the whole this process, this kind of process to be automated and tested. So just I have to write the code, upload it, then this all testing has to be testing and flashing on the microcontroller, and and we have to get the result. Everything should be automated. So that is what the goal was. The company asked me to develop it. So using Jenkins. So what they did is they gave me a Raspberry Pi. So you guys might have gone through, or you might have studied. You can look out for this also. Raspberry Pi is nothing but a small kind of CPU. So so it is having all its same kind of CPU, but it's a small one which can be used for doing our projects, small kind of projects, and to learn new technologies. So along with this microcontroller, this Raspberry Pi, I had ordered a Node MCU firmware where I'm just it has many many things to learn. For my case, I just want to blink the LED and just have to show them whether it is getting automatically triggered. So that is what my goal was. So what I do is, in my laptop, I just write the code. So this is kind of code. If you see here, it is just, if you can see here, it is about the LED. So here LED has to be high, then the LED has to be low. So LED on and LED off. This will blink the LED. Simple as this one. So once this code is done, so there is one more tool called GitHub. It is nothing but our code. Once our code is done, we can upload it in the server. So GitHub is a kind of our own server. we will be having our own ID and we can upload our codes. So once this code is uploaded, what will happen is this Jenkins, will of the software, it will download it in the system, that is the Raspberry Pi, and from there it will do the building, that is the compilation. Why we do the compilation? So that we get the .hex file. So as we, if we, most of the people might have working in embedded now also, so you might have guys have done these projects also. So it's like we need something to be communicated with the computer. So computer language is required. So in order to do get a computer language codings, so what we do is we compile it, we build it. So we get a hex file. So using that, we can flash it to our microcontroller, right? So this is the steps. So I will show you a demo. What happened is, so this is my Raspberry Pi and this is Node MCU, yeah, and this is a system. So this is a GitHub. So GitHub is, as I told, is just a server where we can upload our code, yeah. So here I've just made a changes and I'm committing it. Committing is nothing but I'm uploading my code. So once this is done, what will happen is, actually, as I told before, it is in the server. Now the Jenkins will check out. Checkout is nothing but it will download the whole software, then build it. So build it in the sense it will create the hex file. So once it creates the hex file, as I shown in the PPT, it will also do the unit testing. So it will get the result of this unit testing. It will get the result of this build, whether it is successful or not, and whether the hex file is generated or not, everything. Then it will do the integration testing and the integration testing. Yeah, sorry, integration testing. What it will do is, here integration testing is nothing but our goal is blinking the light, blinking the LED. So what I did is I have written a code such that it will blink for 5 times. So I have written a code for integration testing. It's a kind of code we have to write. So it's a testing code where it will just blink for 5 times. So whether if it works for 5 times, then yes, it will for sure the LED will blink for lifelong whenever the software is running. So that is the goal, right? So this whole process will be done automatically. Yeah, so I have just given the commit, as you have seen here. I have just giving the commit option. Only I have made the changes in the code and giving the commit changes, and I'm just, so after that, so this is the Jenkins tool actually. If it is unsuccessful, it will be red. If it is successful, it will be green. So this all everything I have just shown. It's a trial and version. So sorry, yeah. So here what it happens is it started its own. As soon as I committed, it started the process. It has started to download the software into this Raspberry Pi. So this is the Raspberry Pi software OS. So once this checkout, that is a download, is done, then it will do the building. Building is nothing but to get the hex file, yeah, and even it will do the unit testing. That is the only that function itself is working or not. So only when this is each step is successful, only if this step is successful, only then it will go to the next step. If this build is successful, only then it will go to the test phase. It will just taking little time for building. Okay, so the build is successful, and then it will go to the testing phase. So your testing, as I told, it will the testing that I have written the code is right. We have to blink the LED for 5 times. So that is the testing part. So this node MCU I had a little bit problem. So what I have to do is I have to reset so that it will flash. Actually, here it has to flash into the node MCU. So you see, this is a serial port. So once I do it, I just have to give the ECU reset. So once I reset it, it will flash, and if you can see this blink, the LED will be blinking for 5 times. Hope you guys have seen it. Okay. So the next step will be flashing, and once the flashing is done, the same way where we're flashing every time, it has to just reset. Yeah, so the LED is blinked. So our ultimate goal was to blink the LED. So it will blink just once, because I didn't give whether 5 times or this one. We have to just blink the LED. That is what the purpose was. Next, it has to upload the test result. So in the sense whether our unit testing and the build process testing and the integration testing, this whole testing outputs should be uploaded again. So we have the code uploaded, and even the result has to be uploaded. So that everything will be automated. So this is what the Jenkins is. Jenkins is also called as it orchestrate our process. Yeah, guys. So this is related to this is just an introduction for the process and the Jenkins. So there is many things to be learned, but only if you are familiar with this process, each process, then it will be easy for you guys to go through with this Jenkins. Yeah, guys. Are you? So this is what about the Jenkins. If you have any questions.
Thank you, sir, for that session. Guys, if you have any queries related to the topic, kindly unmute your mic and ask, or else you can put it in the chat box when we read it out.
Okay. So
So,
yeah.
so my name is Abel. I'm a first year student of BTech, so I'm not well at techniques or on technical field. So I have a
Yeah.
doubt. I don't know
Yes.
whether it's necessary or not.
Yeah.
Jenkins are like an open source server, right?
Yes.
Okay. So it was like feeder on Raspberry.
Sorry.
Uh, like whether the Jenkins are inbuilt on Raspberry. Like
No, 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 no. No, no, not like that. It's just like it can be downloaded. It's a tool. It can be. It's a tool, and even it has to be connected with the internet. Okay, and it.
so, Padden, could you please repeat that?
Uh,
Its voice is breaking.
yeah. So it is a tool which requires internet also. Okay, every time it has to be connected, it has to be online. Okay, and it doesn't depends on any hardware or anything. It can be downloaded on I mean, it can work on a laptop or any system, or even on a Raspberry Pi. So that is what I wanted to show in the Raspberry Pi kind of a demo.
Okay, thank you, sir.
Yes. So, if you're first year, it's nothing but it's like just a knowledge. I mean, what's it's just like a technology that is undergoing with the industry. So they are using in the industry. Yeah.
Yeah,
Uh, when you go in further years, so you'll be able to go through. You can adapt this process while doing your projects. So when you're going with the project or any project works, you have a set of process kind of thing like this, so that you will be able to reduce your errors.
okay, thank you, sir.
Thank you, sir, for that answer. We have some questions in the chat box. Shall I read it out?
Yeah, one second. Can you give us a real-time application for Jenkins? What does orchestration means? Okay. As the first one is Emmanuel Manusan. Yeah. So the real-time application for Jenkins. Actually, this is a as I okay a real-time. It's like whatever now it is happening. I mean the ECU, not ECU. In a simple way, if I had to tell that the flashing. Just nothing. We have to write the code and we are flashing on a microcontroller. Just a simple one. Okay. So what we do is once we write the code, we compile it. We do the compilation so that it will change to the computer language, as I told. So it will give the hex file. So that hex file has to be flashed over a microcontroller. Only then that microcontroller can be used as we require, right? So what using this Jenkins, just writing the code and upload it, just giving that commit as I shown in the GitHub, just uploading it, automatically it will build, right? And automatically it will flash. And if there is any additional things to be added, that we can also add. So everything will be automated. So that is the real time of Jenkins. So that is the use of Jenkins. Yeah. So this is what the answer of Emmanuel. Yeah. And for Kritika's son, actually orchestration is nothing but like we it's like that's what the flashing, the building, and all this has to be automated. So we are playing with this Jenkins tool. So it's like Jenkins is nothing but a plug-in play kind of thing. So all the tools that we manually we do, like for flashing, for building, we use a tool, right? Manually, the same tool has to be used inside Jenkins. So that's what I didn't go more detail into Jenkins because it is a vast topic to go through Jenkins. So I just gave you an overview. But if you guys have if you are more interested to learn, can please go through the online and in the YouTube also, because I learned from there, and we were able to get a project related to this. So that is what Jenkins, I mean, the orchestration is all about. And the CI/CD, it's nothing but the continuous integration and continuous deployment. So this is a Kritika's question. So continuous. So continuously, as I shown in the continuous, I mean the PPT when I shown you, the whole process will be continuously integrated. I mean it will be getting the results. So there will be I mean only if the server is dropped, server is down, only then this will be stopped. This process will be stopped. So that is what it will be telling us continuously. So continuous deployment is nothing but once we do the whole our codings and everything, it will deploy our code. So deploy in the server. So that software can be used anywhere. So that is what this is CD and CI means: continuous integration, continuous deployment. So are you guys okay with this one? Yes, son. Actually, yes. It's this is this LED blinking is just a simple. I mean, it's a simple code. So yeah, if for that Node MCU, it was having only 2 LEDs. But if you have in your projects, you can use it for any kind of things. So the same way, what you have in a mind of writing it manually and testing and building everything manually, that can be automated. For that purpose, Jenkins can be used. No, Rajat's languages. Jenkins is just a tool. Actually, it's mainly based on Python. So Jenkins inside itself, we have to write some. So okay, it's like okay. Sorry guys, actually yeah. So Jenkins inside, I didn't show you because I thought it will take more time for me to present. That's why I didn't show you. So this is the Jenkins pipeline. So if you see, this is a Jenkins code. So it will be in a pipeline script, they say, for Jenkins itself, or else it will be in a Python also. Okay. So here, this is a stage. So checkout stage, which I shown you that first is the checkout, then comes the build, then comes the testing phase, then the the flash phase, upload phase, those kind of things will be coming. So this everything is written is in pipeline scripting. So Jenkins supports pipeline scripting and Python. So answering your this one question. So what are the components Jenkins is mainly integrated with? Actually, it's like that's what it's a plug and play kind of tool. So whichever tools that you manually you use the same tools, if it is compatible with Jenkins, so that can be used. So again, once again, sorry guys for taking much time. It's just I'm answering the question.
Okay.
So Jenkins has many plugins. So depending on what tool you are using, so whether that plugin is available or not, so we can just check it here, and so according to that we can work with the Jenkins. So there are many plugins that is available. So suppose microcontroller related, so we can just search here what all plugins is there. Microcontroller, CMake is nothing but a tool which is used for building the software. So it will give a hex file or in .out file. So for that purpose, this CMake is required. So those kind of things, the plugins are there. So CMake is another tool. So instead of using this CMake tool to make Jenkins making the use of this CMake tool, we required a plugin. Yeah, so it is not a single integrated with a component. It is just a plug and play. So we have to plug in our whatever the softwares that is required, the tools to be used. Yes, Arduino, can be used instead of Raspberry Pi. Yes. So anything, whichever manually you do, that if it has to be automated, then you can use Jenkins.
Sir,
Yeah.
I have a doubt now.
Yes.
That for different product, we uses different coding, right? So,
Yes.
how it happens while using Jenkins? I mean, how can it identifies like how it fixes the bug?
No, actually, Matthewson, actually here, Jenkins, you don't, I mean, you are thinking like whether Jenkins will run the code. It will not run the code, it will run the tools. So that is what it is, the orchestration. So it will orchestrate the tools, not the codes inside.
Okay.
Yeah.
Okay.
So,
Yeah.
yes. So
Any
yeah,
queries?
hope
I
you guys.
hope that is all with the queries.
Yeah.
Yeah. With that, we have come to the end of this session. I would like to thank Mr. INBARAJ Dhanpal on behalf of IEEE SB SJCET, IEEE SB NSSCE, and IEEE SB LBSITW, who has, in spite of his busy schedule, accepted our invitation to Insights in 20. As a token of love and appreciation, we present to you with this virtual memento, sir.
Thank you so much. Thank you for your time, and thank you for letting me sharing my experience.
Our pleasure, sir.
Yeah.
Next, I would like to thank all the organizers and student coordinators for enthusiastically managing the event. Last but not least, I extend my sincere thanks to the participants. Kindly fill in the feedback form, which will be counted as your attendance also. The link for the same is given in the chat box.